Hey, good afternoon, everyone. My name is Eric Santelices. I'm a consulting systems engineer with Round Tower Technologies. And today I'm here to talk about some lessons learned and experiences of migrating a customer from 2 data centers on-prem to 100% workloads in the cloud. We used VMware Cloud on AWS as part of our overall solution. And so, as the slide says, this is a rocket ship that we use to catalyst this migration. As we get into the talk, we're going to cover the requirements that the customer gave us, along with how we positioned VMware Cloud to solve the solution, along with Amazon native services. We're going to get into how we leveraged hybrid cloud extension and some of the timelines that we were constrained with during our migration process. We're also going to talk about the lessons learned from a VMware perspective and from a hybrid cloud extension perspective. So, if you're not familiar with what VMware Cloud on AWS is, this is a combination of VMware's technology. It's a software-defined data center, so it's leveraging NSX. It's also leveraging vSAN, sitting on Amazon's hardware in Amazon's data center. You also have high-speed, low-latency connections to the Amazon data center services through elastic network interfaces that are provisioned during the creation and the deployment of your SDDC. So from a technical perspective and from a design perspective, VMware Cloud on AWS allows you to take your existing vCenter, your existing data center on-prem, and extend that vCenter and connect it up to the cloud vCenter. And then with that, you can extend your services into AWS and leverage all of the AWS native tools and capabilities within your SDDC in the cloud. So from a requirements perspective, our customer had 2 production data centers. One of them was in Smyrna, Georgia. The other one was in New Jersey. They were running in an active passive fashion. They were using all VMware technology and Dell EMC technologies to do replication and mirroring between those 2 sites. They would do disaster recovery testing twice a year and fail over their applications to the secondary site for testing. The timeline they gave us was very aggressive. So they had a business event with their DR data center. They had a lease that was up for renewal, and they didn't want to renew their data center space. So our first goal in this project was to get out of and vacate that DR data center. So for us, what that meant was we had to have a copy of all of our systems that were in production, just like we had them in Smyrna, Georgia. We had to have a copy of those systems in the cloud. The equipment that they had was a leased equipment. So shortly after the 6 months lease on the data center, the equipment was coming up on lease. So not only did we have to evacuate the data center, we had to sanitize and cleanse all the equipment and get that ready to return. We had a lot of legacy applications, a lot of big Oracle applications that couldn't be lifted and shifted into Amazon easily in this short time frame. And the customer also had this desire to get to the cloud as soon as possible. From a technology perspective, we were looking at a footprint of around 375 virtual machines, 130 terabytes of data, an Oracle rack cluster, many SQL servers and many standalone Oracle servers were also pervasive in this environment. RTO and RPO was very important for us to capture during this discovery phase because that would drive some of the technologies that we used to set up our replication and to set up the disaster recovery to the cloud, which was our first stage. So after we chose our technology solutions, which was VMware Cloud on AWS and the AWS native platform, we worked with the project management team both at Round Tower Technologies and with the customer to develop this timeline of when we had to have things executing and when we had to have things migrated to the cloud. And so you can see here that we've laid it out of what parts we went through an application rationalization exercise with the customer, trying to identify parts and components within the environment that could easily move or migrate into Amazon with a low level of refactoring. Being the fact that we had VMware technology, we were able to keep a lot of their legacy systems on VMware, things that were constrained by licensing or things that were constrained by other elements that we could not easily duplicate in Amazon's data center for this rapid migration. So when we get into some of the native services, VMware Cloud on AWS today does not offer load balancing natively within the NSX stack, so we had to replicate and rebuild. We didn't carry over any of the legacy infrastructure. So we had to go and map all of those load balancers and build out those web servers in Amazon on the native platform using the native services. We leveraged Route 53 for all the DNS, which means that when we got off of the legacy load balancers, we also had to migrate all the global load balancing namespace over to Route 53. I mentioned we had quite a few SQL servers. There was a lot of archive servers, database servers that we had, or servers that we had that had legal hold. And so those servers, we replicated those into RDS, and we did, using database migration services from Amazon, we're able to replicate those databases into RDS. And then everything that we did within the environment, because one of our constraints also was cost, we leveraged CloudFormation to stand up the SDDC and use CloudFormation to design and lay out the VPCs and the AWS infrastructure. Because one of the constraints that we had was we didn't want to run an active-active cluster or run an active-passive cluster between Virginia and Oregon. We wanted to be able to meet those RTOs and RPOs by spinning up that cluster on demand and using backup and recovery technologies within the cloud to restore those systems and make them whole again in the event of a disaster. So CloudFormation is critical from that perspective. We set up an entire CI/CD pipeline within Amazon using code deploy and using Amazon's services for code management to be able to give us that agility to be able to spin up an environment either in Virginia or to spin up that environment in Oregon. So when we got into how we were going to move these machines in a very quick fashion with the least amount of disruption to the business, we started searching for technologies, and one of the capabilities that's available with VMware Cloud on AWS is the hybrid cloud extension. So HCX gives us a couple of things. It gives us a WAN optimizer. So even though we didn't have direct connects established yet, we were still able to start replication and start moving some of the systems to the cloud because there's a WAN optimizer. There's also layer 2 extension. So with the layer 2 extension, we were able to build a networking substrate that allowed us to connect our on-prem infrastructure to the cloud and start those migrations of machines without having to re-IP the infrastructure. So some of the features of HCX. HCX also gives you replication, it gives you the network extension, and it gives automatic failover support. Another reason why we chose HCX as part of our migration strategy is that we had some vCenters that were down version, and we didn't want to have to go through a vCenter upgrade to connect it to the SDDC in the cloud, so we used HCX to migrate virtual machines out of the on-prem infrastructure on those lower versions. One other thing that I'd like to point out is that even though you're moving, or the SDDC supports NSX in the cloud, you do not have to have NSX on-prem. Same thing for vSAN. You can use the SDDC in the cloud and use vSAN in the cloud, but you don't need to have it on-prem. From a migration perspective, there's a couple of different ways that you can migrate with HCX. So when you have your connectivity established, you can do a vMotion between on-prem and the cloud. But because we were looking to do migrations, we had certain application stacks that needed to be moved together. And so once we found out and identified what those dependencies are, we were able to create those migration waves and then stage them within HCX and schedule those migrations to occur. And so just like a vMotion, when you execute a migration, it copies all the bits to the target site, and then when it's ready, when it's cut over time, it keeps those systems in sync, and when it's cut over time, it stops the on-prem versions and starts the cloud versions. And so that's where we were able to use either single migration or bulk migration, which is that reboot into cloud. And lastly, as I mentioned earlier, we use this as a disaster recovery mechanism. So the first thing that we did was we took those 375 machines and started replicating them all out to the cloud. As soon as we had image consistency in the SDDC, we were able to stand up in an isolated environment and test those virtual machines to ensure that we had data consistency and to ensure that the applications worked. And that gave us that level of confidence to be able to go back and then start shutting down and decommissioning that secondary data center for disaster recovery. So a couple of things around hybrid cloud extension. So VMware Hybrid Cloud Extension is a network appliance. It deploys into your vCenter, and it deploys per VDS. It assumes that all VDS uplinks are equal, so it's a disjoint layer 2. You must have a routed vMotion network in order for live migration to work between on-prem and the cloud. When you deploy HCX has to be deployed into a network. That network that it gets deployed into cannot be stretched between the two clusters. So if you're going to be using HCX, just think about creating like a /28, a small network that you can have your HCX appliances live. Once your VMs are protected by HCX, you cannot extend your disks. So in our situation, our project and our timeline was running over 6 months. And we had some systems that were running up against full disk capacity. So we had to start going into the operating system and looking for opportunities to clean out and free up storage for us. So just keep that in the back of your mind. That could be a catalyst to force a failover early, but if you have interdependencies with other application stacks for those systems that are running hot on their disk, that needs to be addressed. Live migrations have the same limitations as vMotion. So if you have an AMD infrastructure on-prem, you're not going to be able to do a live vMotion directly into the cloud because the cloud on SDDC is all Intel hardware. VMware support. So within the VMware cloud on AWS, you have a web interface, and at the bottom of every screen, you have this little icon there for support. The support team that we encountered is phenomenal. They are a great support team. They're very knowledgeable. It's not your typical, you call in, you get level 1, they ask you a bunch of questions, did you reboot it, you know, those kinds of things. It's really, because they have visibility into your SDDC with their support system that they have, when you're having a problem, it's contextual. When you're telling them, I'm doing this thing and this thing's not working, they're able to see what you did and play back and look at the history of where you were and what you did and the problem that you encountered. And then a lot of times, because this is a managed service, the support team is able to go in underneath the covers and touch the bits that we don't have access to from a cloud management portal. And they're able to remediate the issues that you have. And then lastly, VMware will support automatically adding nodes to your cluster. So the SDDC is an on-demand service. You can start with as minimum of 3 nodes and then grow your cluster as you need more. Well, one of the elements that is a restriction or is an opportunity for growth is your storage. In our environment, we were bound by storage before we were bound by CPU or memory. And so when we were adding machines and replicating them, the SDDC started to grow, and it started to grow naturally because as we hit that 70% threshold, VMware's managed services automatically added another node into the cluster and automatically restretched that vSAN so that new storage was available to us. One other lesson learned, which is not listed on the slide here today, is the fact that when you go above 5 nodes, your FTT switches from 1 to 2. So you're essentially going from RAID 5 to RAID 6. So that's really important to understand when you're calculating the size of your cluster. Luckily, VMware has now provided us with a pricing calculator and a sizing calculator. If you go to cloud.vmware.com, and you can put in there all of these elements, and it will automatically adjust your cluster for you and tell you how much you need from a cluster perspective based on the storage requirements. So something else that's a little bit different than some of you may have your environments created on-prem today is that the management network truly is a separate, segregated network than the compute network. I know a lot of us put them in separate buckets or they put them into separate folders, but it's all the same resources. These are completely separate environments. So you have to manage NSX and you have to manage your security policies between the management network and the compute network. So things like single sign-on or Active Directory integration for vSphere, When you integrate that, you have to create the specific networking policies or networking routes between the management cluster and the compute cluster if you're going to be authenticating against an Active Directory machine inside of your compute resources. Because naturally they are separated, and naturally they will not speak to each other. And so what you can see here is a depiction of the number of firewall rules that we have between the compute cluster and the internet, the management cluster and the internet, the management cluster and the compute cluster, and then ultimately the compute cluster and Amazon EC2, or Amazon services. And so in the bottom, what we're showing there is the private public addresses for authentication, DNS lookup, name resolution. If you have those resources inside of the SDDC, you have to take that into account during your design phase. So after we had our initial timeline, as we got into the actual implementation, we were iterating, and we had to continuously improve our process. So we had a more modernized or a new streamlined timeline to actually get to our destination date. And so this is the same view that we saw before, but this is the actual implementation and the actual cutovers for this project. And the outcome was, we did it, right? So 6 months, shut down 2 data centers, thousands of servers, cleaned and swept the floors, sanitized the equipment, returned it to the vendors. The biggest thing that we learned during this project is that the things and the assumptions that we made in the beginning and the decisions that we made in the beginning could not remain persistent as we went through the entire project. So communication between the different teams, between storage, between networking, and between the Amazon native teams and the VMware teams was critical as we continued to learn and as we continued to understand some of the limitations or some of the capabilities that we had now with these new tools that we were using. So iteration is very important. You got to understand what you did, learn from those mistakes, and continue to iterate. From a project perspective, we actually did the cutover, the final cutover, this past weekend before Thanksgiving. It lasted 30 hours to cut over the final production systems. Monday morning we had an all-hands call where everybody was on the call, all the technical resources, all the project resources, and business unit owners as the company came back online and as the folks were arriving in the office. And by noon, the project was a success. It was the executive sponsor at the customer's account declared the project a complete success because the only things that we were dealing with was not end user technical issues or the platforms were unavailable. The issues that we were dealing with were simple things like this one web server sends out email and the SMTP gateway is not configured properly. We need to address that issue. So there were minor technical changes that we had to do that day of that we rolled into production, but to the end users within the business and external to the business did not experience any issues during that final cutover day. So any questions?